Hello friends. This video is brought to you by mywayteaching.com.
Triangles. In this chapter, we will introduce you to similarity of triangles. Then we shall discuss the criteria for similarity of triangles. We shall then understand the relation between the areas of similar triangles. Finally, we will prove Pythagoras theorem using the concept of similarity of triangles and solve some examples on it. We are familiar with the triangles and many of their properties from our earlier classes. Let us recall that congruency meant that if two things can completely overlap on one another, that is, they have the same shape and the same size. On the other hand, two figures having the same shape and not necessarily the same size are called the similar figures. Let us try to understand both the definitions. Let us see at these two circles. Since they have the same radii, they are congruent to one another. They can overlap each other. Now consider some more circles. Since all of them do not have the same radii, they are not congruent to each other. Some are congruent and some are not, but all of them have the same shape. That is, they are all circles. So, they are called similar figures. In other words, two similar figures have the same shape but do not necessarily have the same size. Therefore, all the circles are similar. This also makes us conclude that all congruent figures are similar, but the similar figures are not congruent. This is a very important result which will be used while proving that two figures are similar. Sometimes we may use the congruency property to prove that two figures are similar. Now, a question arises, can a circle and a square be similar? Can a triangle and a square be similar? Evidently, these figures are not similar as they are not of the same shape. Now suppose we have two quadrilaterals ABCD and PQRS, and the question is, are they similar? These figures appear to be similar, but we cannot be certain about it. Therefore, we must have some definition of similarity of figures, and based on this definition, some rules to decide whether the two figures are similar or not. Look at these photographs of the same monument. Although they are different in size, but still we can say that these are similar. It also means that every line segment of the smaller photograph is enlarged to some ratio to get a bigger photograph. Further, if you consider angles between any pair of corresponding line segments, then in the two different photographs, we shall see that the angles are all equal. This is the essence of similarity of two figures, and in particular of two polygons. Hence we come to the rule of similarity of polygons. two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in same ratio or proportion. In the two figures, quadrilateral A dash, B dash, C dash and D dash and the quadrilateral ABCD are of the same shape but of different sizes. If the two quadrilaterals are similar, then it would mean that the side A corresponds to A dash, B corresponds to B dash, C corresponds to C dash and D corresponds to D dash. By definition, angle A will be equal to angle A dash. Similarly, angle B equal to angle B dash. Angle C equal to C dash and angle D equal to D dash. And by second part of the definition, AB by A dash B dash will be equal to BC by B dash C dash, CD by C dash D dash and DA by D dash A dash. Also note that for the two quadrilaterals to be similar, both the conditions need to be satisfied. Only one of them is not sufficient to prove they are similar. Also, the ratio for all the sides should be equal to each other. For instance, consider a square and a rectangle. Both of them have same number of sides and also the corresponding angles are equal since all the angles are of 90 degree in both the figures. But still, the two figures or the two quadrilaterals are not similar. This is because their corresponding sides are not in the same ratio. If we consider a square and a rhombus, the two figures may have corresponding sides in the same ratio. That is, all the sides of the square will be 2.1. So 2.1 by the corresponding sides of the rhombus will be in the same ratio. That is 1 by 2. But the corresponding angles are not equal. So again the two polygons are not similar. This brings us to the conclusion that either of the two conditions of similarity of two polygons is not sufficient for them to be similar. In other words, both the conditions have to be satisfied for two polygons to be similar. That is, their corresponding angles should be equal and their